about ISSE and this activity first, and then our speaker today. So, good morning, everyone. On behalf of ISSE, and this is a 11th session which we are having in the student webinar series. And although it was started as a student webinar series, now the activity is becoming so popular that all senior faculties are also finding it very useful. Uh, so you all know about ISSE. ISSE is a 30 years old organization, and there are several publications like this is on a corrosion is there, then this is on a audits is there, then this is on a shear walls is there. So there are several publications available on ISSE. So you can visit ISSE website and get to know about ISSE publications and how is the membership procedure, what are the fees criteria, how to open student chapter, how to maintain it, and all those things are given on the ISSE website. So now today we have with us Shri N. Bandhu sir. So I will officially introduce him, and then I will hand over it to him to take the session further. Sir completed his early education from Sitamarhi, Bihar, and which is a birthplace of Sita Maya. And see the coincidence today that today is Sita Navami. I'm just checking the calendar, which is a birthday of Sita Maya. So what a great coincidence we have. Then Sir completed his pre-engineering education from Patna, and later on he moved for AMI and joined Institute of Engineers. With hard work and dedication and persuasion, he completed his engineering education through this alternate route available in India. He started his professional career journey in year 1986 as a site engineer with a company called as a Piling Engineers. Since then, he had been working on several interesting projects such as Kahalgaon Super Thermal Power Project, then suspension bridge over Lathoma River, Bihar Plateau Development Project, which was a World Bank funded project, and many more. After 12 years of rigorous site exposure, he rose to a position of resident engineer, and since then he started working on with eminent consulting firms like ICD, Sheladia, Sai Consulting Engineers on various interesting projects in various capacities like bridge engineer, team leader, and alike. Many of us, we learn engineering in colleges and AC offices or rooms or in front of the computer screen. Whereas Sir has actually experienced engineering in real life challenging projects. After a robust experience of 23 years in 2009, Sir acquired a position of Assistant Vice President in Reliance Infra. Subsequently, he also worked with Louis Berger, LBG, and Sistra India as a chief engineer. In year 2022, he established his own firm as independent bridge and metro rail consultant. He did noticeable contribution to Mumbai and Navi Mumbai Metrorail project in several other projects, may it be a depot development or other construction aspects. Sir is a fellow of Institute of Engineer, Institution of Valuers, member of IRC, IIB, IGS, and approved valuer. Varied experience in execution planning ranging from piles, well foundations, pile load test, 62.5-meter PAC box girder, 55-meter steel plate girder, cable stay bridges, span load test, derailment test, and such many more. Sir has acquired more than total 40 plus years of experience. He has been very active in civil engineering profession and a senior mentor and advisor, always ready to help budding engineers and ready to share his knowledge without holding anything back. He is a visiting faculty at CEPT University Ahmedabad for MTech classes in metro rail construction. Previously, he has conducted several lectures at IEI, IIT Bombay, Datta Meghe College of Engineering, Saraswati College, Navi Mumbai, SAIT Indore, and many more. And he also wrote technical papers on bridges, metros, bearings, durability aspects of infrastructure in India. He critically and fearlessly competed and wrote on the ground analysis which wherever he found in bridge and metro construction industry. His interview published in YT channel, YouTube channels were appreciated and inspired many of budding engineers. So let us welcome Sir to start his presentation on pre-stressing of bridges, activity, issues and remedial measures. And believe me, there are several more interesting topics which Sir has like bearings, launchings and many more in his knowledgeable, magical knowledge bank, which we are going to explore in the coming months. So over to you, Sir. You can
Good
share.
morning.
Yeah.
Can you listen me, sir?
Yes, sir.
Yeah. Good morning, my friends. I would like to share my experience and everything. First of all, sir, there is a reflection. What I am telling, I am listening.
I think you can remove the you are on a this thing, no, sir. You're on a laptop, so you can
Hello?
remove the headset. Yeah,
Yeah,
you can remove
yeah.
your headset and try.
Now it is okay, sir. Yeah.
Yeah, sir, you can
I would
start
like
the
to
presentation.
extend my sincere thanks. Oh, same thing is happening.
Yeah, you can remove the headset, sir.
Okay.
Yeah, from the slot also you remove. From the slot
Hello?
also you remove. Yes.
Hello?
Yeah, yes, sir. Sir, you can remove the cable from the slot, the audio slot.
Now it is okay. Can you listen me?
Yes, sir.
So same thing is happening.
Sir, you can
What
remove
am
the yeah, you can remove the audio slot and you can use this the laptop speakers directly.
Hello?
Hello.
Hello?
Yes, sir. Hello.
Hello?
Yes, sir. We are able to listen.
Just
Okay.
hello.
Yes, sir.
Yes, please. Uh,
Yeah.
I would like to extend my sincere thanks to all organizations, especially Vivek sir, who has given me an opportunity to share my field experience, and I will try my level best to make it interesting and knowledgeable. And whatever problem I have seen my in my life, I would like to share with you so that our field engineers must learn and follow to sort out all the issues. Today's topic is pre-stressing in bridges. Pre-stressing means stress we have to give before loading, whether it is load of dead weight or live load. That is why it is pre-stressing. In earlier days, in the earlier days, mobility of human being was badly obstructed by rivers. The only to cross the river option was either by swimming or use of country boats. Bridges are the only permanent solution to cross the river and other obstructions. This is one of the important elements of transportation infrastructure system. Journey of bridges starts accidentally by fallen tree across the river. Subsequently, bridges were constructed by wooden logs, stones, bricks, PCC, RCC, PSC, steel, or its combination here too. Several activities are involved in the construction of bridges. Prestressing is one of them. Prestressing itself has no use unless until it is supplements to the concrete. Time and accuracy are the essence of prestressing. In case of post tensioning, grouting is the supplementary activity which makes the stressing system effective and durable. The journey of
Hello, sir.
stressing is the
Sir,
start.
you have to share your PPT. Sir, you have to share your presentation.
Oh, oh, it is not there.
No, no, you have not yet shared, sir. On the right
Okay.
top, there is a icon I share.
Right top.
Yeah, there is a
Yeah.
icon for sharing.
Mhm. Share. Yes, yes, sir.
Yeah, then you can share your whole screen, entire screen.
PowerPoint presentation. An error occurred. Oh, it is coming share, then link to the slide.
Yeah, you have to share the entire window, sir. You have to share entire window and then you can start your presentation. Then you will not
Oh,
be able to see the participants, but you will see the
okay.
screen.
One share is coming, then share,
Yeah, you
then it's
can.
coming share, upload your presentation to share it.
No, 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 don't upload it. You can share the screen.
Okay.
Sir, you go to share button.
Share, yes.
Yeah, and then there is a screen window tab available. So you can click on there.
Get it is coming five items like share, copy link,
Yes,
link to this slide, get PowerPoint mobile app, and manage access.
yes, yes. Or else if you can share it to me, then I can present it on your behalf, sir. Then you can speak.
Okay.
If you have shared in WhatsApp,
Uh,
because I have a PDF, I don't have your PPT.
okay. Okay. Just a minute, please.
Should I share the same slide? Yeah.
Once again, I am starting. Whatever link has been mentioned, just I click it. It is coming. Join your Teams meeting. Continue on this
No, no,
process. Another is join on the team apps.
no, no. You are not supposed to join again. You have already
Okay.
joined the meeting. Now you have
Okay.
to go on the share icon. And sir, I will share the presentation because I have a copy.
I will share you now.
Just a moment. I have a copy, so I will share. Then you can instruct me.
Just a minute. Let me try.
So can you see the presentation now?
Yeah, it is there.
Yeah. So
Presentation.
you can also share like that, sir. Yeah. Can you share the presentation? See the presentation.
Yeah, I can see.
So you can do like that, or should I operate on your behalf from here? Hello, hello, hello. Yeah,
Just a minute, please.
yeah. Yes. So you can click on the share content. You can there is a top icon, share icon. You found that share icon,
Okay.
sir?
Yeah. Tell me, sir.
Yeah, you click on share this button. Then there is a
Okay.
screen window or tab is coming.
During share,
Yeah, share content will come.
it is coming attach a copy instead.
No,
PowerPoint
it is
presentation. Something went wrong.
no. Yeah, sir, you have joined using external or you are in a Microsoft Teams.
Yeah.
So what is a command coming there? Hello, hello.
Now PPT has come. While sharing, it is coming share.
No, yes. Now you share.
Then it is coming share. Now
Yes.
please upload your presentation to share it.
No. Okay, you try that option. Upload.
It is a OneDrive personal.
Sir, sir, are you trying to share from the team app or
moment.
Microsoft presentation app? Sir, are you trying to share from Teams app or Microsoft presentation app? I think you are on a PPT. That's why it is coming.
No, sir. Should I present the slides from my system? You can see.
Just I am quitting here and once again logging in.
Yeah. Okay.
Can you log in?
Yeah. Sorry for the inconvenience. I think there is some sharing issue happening.
It has come now.
Hello, sir. You are joining from a Teams app or a browser.
This is browser, sir.
Okay, so if it is a browser, then on the top there is a icon. Sir,
Okay.
you need not to share from PowerPoint. You have to go to Teams app. You go to Teams. Are you able to see? Sir, please keep yourself on mute.
Yeah.
Sir, you are logging from, you're seeing from the Microsoft Teams or PowerPoint?
That I can't say.
Sir, should I share the slides from my system और आप मेरे को
Yeah.
share कर दें? Yeah.
हाँ, okay. Just I am sharing on WhatsApp. Okay.
Yeah, please.
Please.
Sir, you have already shared me the PPT. I
Sir,
can use
it is,
PPT.
it is not PPT. It is not PPT.
No, you have shared the PDF. Should I use the PDF for the slide?
No, I will send it in PPT. It will take.
Okay. Have you shared? Hello.
Just a minute, please. It is going now.
सर मैं आपको फोन पे इंस्ट्रक्ट करता हूँ. गिव मी अ सेकेंड.
अच्छा, okay. Technical. Yes, sir. अच्छा. हेलो. मैं कर दिया सर, हो गया. हाँ हाँ हाँ, ठीक ठीक है सर। ओके सर, ओके, थैंक यू वेरी मच सर।
Sir, you can
Yeah,
start
good
your
morning sir.
presentation.
Yeah, good morning sir. Now we are
Good
talking about
morning.
pre-stressing. Pre-stressing means stressing before any load, whether it is dead load or live load. That is why it is pre-stressing. And pre-stressing is used in bridges. In earlier days, mobility of human being was badly obstructed by rivers. The only option to cross the river was either by swimming or use of country boat. Journey of bridges start accidentally by falling tree across the river. Subsequently, bridges were constructed by wooden logs, stone, bricks, PCC, RCC, PSC, steel, or its combination here too. Several activities are involved in the construction of bridges. Prestressing is one of them. Prestressing itself has no use unless until it is supplements to the concrete. Time and accuracy are the essence of the pre-stressing. In case of post-tensioning, grouting is a supplementary activity which make the stressing system effective and durability. Introduction of pre-stressing to concrete was pioneered by Prestressing. First pre-stressed concrete bridge in India was constructed in 1948 for a span of 12.8 meters in Siliguri on Assam Link Rail project. First PSC girder for highways was constructed in 1954 with 23 a span of 27 meters on Palar River in Tamil Nadu. First balanced cantilever bridge was constructed at Buxar over river Ganges in 1971-75. Subsequently, Gandhi Setu was constructed and inaugurated in 1984 on Patna, and by that time it was the longest river bridge in Asia, 5775 meter. This is the journey. This is the number one is fallen tree. It was used as a bridge. Then wooden log, almost simple HPC. Number three, fume pipe culvert. Then come to arch bridge. It is constructed with bridge. Then a stone masonry. You can see it is a three-tier construction. Then RCC box culvert. Then a slab bridge, RCC slab bridge. And to increase the span, weight has to be reduced by voided slab. Void maker can be seen here to reduce the weight. Then RCC T-beam, then pre-stressed concrete I girder. It is full span. And number 11 is segmental also. Suppose any traffic issue is there for cast in situ or erection purpose, then you need to do segmental also. This is a bow-string bridge, number 12. Then the segmental box girder. A balance cantilever bridge. And number 15th is Havra bridge. It is balanced cantilever with simply supported of 172-meter span. Then arch bridge, cable stay bridge, and suspension bridge. Suspension bridge can be extended up to 2033 meter. Now recently it is to be inaugurated. Coming to steel bridge, first 19 number is plate girder. This is known as deck type plate girder. And number 20 is through type, because here load is at the bottom and 19 load is at top. So it is through type. Similarly, truss girder also. Truss 21 is through girder and 22 is deck girder. And now this 21 through girder is known as open wave truss girder. Now coming to pre-stressing, how it works. This RCC versus PSC. Diagram you can see, sir. Vivek, sir.
Yes, sir. Yes, sir. We are able to see.
Yes, sir, it is
Yeah,
visible.
yeah. Okay. So this concreting, after concreting, whether it is RCC or PSC, there is no stress. But in case of RCC, once shutting is removed, load comes on girder receipt. So at the bottom there will be a tension, at top there is a compression, and after loading this compression at top increases. Similarly, tension at bottom also increases. That is why there is chances of cracks, and this crack is admissible up to 0.2 mm also. But in case of PSC, there is no tension. Just you see number one, only vertical line is there. It means no tension, no compression. But after stressing, there is a compression at bottom. At top, there is a neutral, no tension, no compression. But after loading, at the top, compression comes, and a resultant will be at the bottom, there will not be any tension, but at the top, there will be compression only. So how it works? Prestressing, function of prestressing is to compress the structure, and at the same time, self-lifting mechanism is there. Like a rope, we are hanging our clothes. Similar way, it works here. So prestressing activity is an arrangement which deployed permanently in concrete. It boosts up the tensile strength of concrete members. It applied which increases an axial compression that counteract with the tensile stresses set up in the member due to dead load, live load, or accidental whatsoever may be. There are several advantages. With PSC, we can have larger span and section remains on cracks. We have seen in previous, there is no tension at the bottom, so it is on crack and suitable for precast construction also, and very fast construction due to repetition possibility. And in case of precast, better QC is possible due to factory type environment, but there are some limitations are there and issues are there. So it requires highly skilled technical manpower due to precision work, relatively higher cost due to the casting yard setup and requirement of auxiliary equipment. Design is more complex. Chances of slip of wheels is there, breaking of stands is there, punching of anchor cone or bursting of concrete, and leakage is seething. These are the issues and limitations. So we are having several type of pre-stress structure. Simplest is PSC eye girder. You can see eye girder has been erected, and here eye girder, since several students are there, so I am explaining in detail. In eye girder, three components are there. One is top plane, bottom plane, and vertical known as wave. Bottom plane is also known as bulb. So this is the PSCI girder, simplest one. Then box girder. Box, it is confined box. That is why it is known as box girder. Bottom known as soffit, and side, it can be vertical or inclined, known as wave. And at the top, this top slab is known as deck slab. Similarly, PSC segmental box girder, it is cast in pieces and stressed and grouted to make it one piece. Then PSC U girder, as name implies, it is U type. It is more common and preferable for Metrorail structure. And balance cantilever, this is the longest possible structure. Then this is for monorail. This is known as guide way. This is vertical beam only, having 0.8 meter width. Then voided PSC slab, and it can be segmental also. PSC voided segmental girder. It's a PSC pier cap. This can be cast in situ or precast to make the headroom more and lower down the deck slab. When PSC portal, sometimes portal is required to reduce the section. PSC is used. Cantilever. This is the cantilever and this is PSC. And number 13 was not PSC. Actually, it's a story from DMRC. Earlier, there was a provision of portal, but some people, shoppers are not allowed to make one pier one side. Then they have converted to
reduce our burden in addressing the requirement.
Converted to portal, and then it collapsed. Another is very important.
Sir, you are
muted.
Sir, you are mute. Hello. Okay, let me check.
Sir, you are muted.
Mayur, can you unmute?
Hello, just checking, sir.
Mayur, can you unmute, sir? He is muted. Mayur, can you unmute?
No, sir. No, not from my side, sir.
Just a moment, I'll check.
हेलो
सर आपका म्यूट हो गया है सिस्टम.
हाँ कैसे हुआ है
नहीं, ऊपर में वो है ना चैट वगैरह, उसमें जाके कीजिए अनम्यूट. अनम्यूट कीजिए, उसमें सिस्टम में आ जाइए सर.
हाँ सिस्टम में आ
हाँ, अब हो गया. हाँ,
Yes,
आ
sir.
गया.
Yes. Yes, sir. आ गया,
स्क्रीन
sir.
पर आ गया. कैसे अनम्यूट हो गया था? Anyway.
Okay.
Yes, sir. This is we are talking about extended pier cap. Here, this is the actual example of Mumbai Metro Line 1, where one Mithi river is there. Due to Mithi river, we have to have our pier either side of bridge, river without obstructing. So, and our U girder was 30 meter, and we were not able to change here. So, we have provided extended pier cap of 18 meter. So, instead of 30, our obligatory span were 48 meter. This is the use of this extended pier cap. Now, PSC, sometimes we have to use prestressing system in deck slab also. Then cable bridge, it is also required prestressing. And sometimes we are using PSC in building also, building slabs, railway slab, railway sleeper, and electric pole. These are the use of prestressing system. Now we are talking about type by casting and stressing sequence. We are having two types. One is pre-tension, another is post-tension. Pre-tension means we have to apply force before casting. And post tension is, first of all, we have to cast, and we have provided a duct hole for the insertion of a stand, and after hardening, stitching is done. And by a stroke, it can be a single stroke, two stroke, or multi stroke. Because a ram having some limitation, the ram in jack having some limitation. So if elongation is up to 200 mm, then single stroke jack will be sufficient. Otherwise, we have to have more than one stroke. Sometimes, due to technical issue, we have to use it 3 stages. I have given one photograph with for eye girder with 2 cable at the bottom. Both are eccentric. Suppose anyone is stressed up to 100%, then there will be chance of bend. No chance. Definitely it will bend. So we have to stress 25% only in one, then go to 50% another. So difference will be only 25%. So there will not be any chance of bending. So we have to take care if 2 or more than 2 cables are there at the bottom. Sorry. Now stage wise. Sometimes we cannot stress all the cables at a time in one go. So in that case, the problem is if we stress, there will be chances of tension and hogging will be more. So we are stressing few cables, then loading is given, stressing, loading like that. So whatever hogging is there and what is hogging, that will be compensated after loading. Then once again it is stressed. So it is stage wise. Next is as per jack position. For shorter span, we are using one end stressing only. And if it is longer than 40 meter, then we are using both end stressing. So now coming to anchorage system. This is the key accessory, and use of anchorage system is to just hold the stressed stand in position without any losses. It's a combination of anchor cone, bearing plate, wedges, spiral bars, etc., which is used to hold the tendons in a stress condition. And same time, it used to transfer the load. Here we can see the photograph, and second photograph in which a spiral has been placed is not correct. It should touch as near as possible to the outer face. And we are having several type of anchorage system. So 4T13. Here 4 means 4 number of a stand, and 13 means 12.7 mm dia of the stand. Like 7 means 7 number, 12T13, 12, 19T13, 19. So 7T15 means 15.2 dia of a stand with 7 number. This is nomenclature. Then at the bottom it is monoblock. Number 6. Generally it is used for pre-tension. Just we will see on another slide. This accessory, this is known as anchor cone or anchor tube or guide cone. Here provision is made in first, we can see this hole, sheathing will rest here. Here sheathing will rest. And this point is made for grouting purposes. This is number 3, we see this hole. And this 4 hole, a small hole, is meant for grout pack fixing. We have to fix the grout cap after spacing, and grout has to be done. And we can see here, number 4, grout cap has been fixed here. And this is used to fix the nipple. Now coming to sheathing. Sheathing, we are having 2 types. One is bright metal sheathing, another is SDFC sheathing. High density polymer, HDPE. And a left side is meant for bridges, whereas this is flat for slab. It can be used in slab also, deck slab also, and building also. And here diameter varies as per number of stand. Here total area, internal area should be more than the total area of the stand. And only 1/3 area of stand is allowed here. So 2/3 space should be there so that grouting will be effective. One important thing is jointing. Here jointing is done. Left side, number 1, one heat shrink coupler has been placed. You can see. Vivek sir. Hello.
Yes, sir.
Hello.
Yes, sir. You are audible.
Just I want to confirm whether I am talking or
No.
is it
You
okay?
are audible. We can see the slides also. You can continue, sir.
Okay. So here this heat shrink coupler. This is known as heat shrink. Once it is heated, in next slide you see same corrugation is coming on the coupler also, and there will not be any leakage chance. There is no chance of leakage. We will see on another slide how it is tested as a leak proofness and strength as well as strength also. And here we can see all anchorage system, and we have to make it watertight. There should not be any leakage. A spiral can be seen, and bursting reinforcement mesh has been used here. Another accessory is base plate or bearing plate. It is cut in pieces and hole is made truncated cone hole, and after fixing it will look like this, number 5. Then wedges. It is cut in pieces with this length, and this shape is given, and after giving this shape, this threading is done. Threading like number 6, photo number 6, we can see threading is done. But one precaution is that this thread should not be sharp to cut the stand. If it is sharp, this thread should be blunt. It can be grip, but no cutting. And after making this hole, it is cutting piece. Number 2, we can see it is being cut in 3 pieces. It will come 3 pieces, and one spring wire. A spring is here to hold 3 pieces at one. Now, main strands. Generally, it is 7 ply. We have considered 15.2 mm dia, 7 ply, and mostly we are using 12.7 or 15.2. It has high strength, adequate ductility, low relaxation to reduce losses, bendability, high bond with grout, concrete, especially pre-tensioning, minimum corrosion is there. Now coming to test, before stressing, we have to do several things. So first of all, we have to have anchorage efficiency test. Anchorage efficiency means while stressing, it should not break due to bite, base bite or anything. And it should be safe for 95% of breaking force. Then load transfer test. This is the actual preparation. Actual cone has been fixed here. After cone, with the horizontal jack is there. By jack, load is being transferred. Here 80% of UTS we can go, and this resistance has been fixed here. Resistance is there, and this is also connected with Q without any stress. So we can see on monitor if any the minor crack is there, even it is not visible. We can see on monitor. So this test is, this is horizontal, and same thing has been kept vertical, and vertical jack has been applied to give the force. So these two, this one anchorage efficiency test and load transfer test is known as system acceptance test. Before approval of system, we have to conduct these two tests. Then this is field test, jack efficiency test. We have to see it should not be less than 95%, and this percentage efficiency has to be incorporated while modifying the jack force into pressure. Now, measurement. This is for typical 15 to 1860 P grade. So we have to measure diameter of all 7 ply, and out of 7, 1 ply, 4 ply, center point is straight, otherwise all are a spiral, and their dia should be 1.5% more than the outer. And diameter of a stand, there is a limitation. This is as per this grade. A lay length we see at the bottom we have given on graph. So here 1, 2, 3, 4, 5, 6 is there. One is inner, so we cannot see. So this is just carbon pressed. So this point to this point is lay length, and there is a limitation 182.4 and 243.2 mm. And straightness. This our stand, after cutting a stand, there should be a straight, but there is a limitation of 25 mm with 1 meter, 1 meter length. If we keep on level table or level surface, then this should not be more than 25 mm. This is the requirement. Area of a stand we have to see, and weight and modulus of elasticity, and 2% proof load, braking strength, elongation at braking load, and a relaxation test also. Here bottom photograph, it is braking load is being tested. So just I want to show one video. Not coming. It is not coming, sir. Video is not coming anywhere. So this is the relaxation test. Here load has been applied. Here this green is load. After 100 hours, load was reduced like this. It is drawn on a semi-log graph, and it is extrapolated to make it 1000 hours here. So this is the graph for load, and this is graph for relaxation. This relaxation has gone here 1.8% or so. So coming to SDP sheathing, this density requirement is density, shore hardness test, tensile strength, elongation at yield, melt flow index, Charpy impact strength, Charpy impact strength at minus 40 degree also, and coefficient of thermal expansion. These are the requirement for raw material. Just I want to see whether we can see. No, sorry. So photo I am unable to show it anyway. So now on product, what are the tests required is the carbon black contact test. Requirement is 2%, more than, it should be more than 2%. Minimum 2% is required, and it helps us to avoid any ultraviolet effect. Then wall thickness we have to test, and diameter also. Workability test, bendability test, transverse load rating test, tensile load test, water loss, whether it is water leak proof or not. Then wear resistance test, or reduction in wall thickness test, bond test, and friction coefficient test, and oval coefficient test. These are the tests required. Practically, how to measure wear resistance test. First of all, we have to cast 30 centimeter cube, and over that half cut sheathing has been placed. You can see it is placed on jack having 5 kilonewton weight load, and we have to pull by 200 mm with single pull jack number 3. Then there will be one impression number 4, and it is measured how much it has gone and how much it is balanced. So their balance thickness should not, residual thickness should not be less than 1.5 mm for 85 mm dia, and 2 mm for more than 85. Here, why it is required to be tested? Because our profile is parabolic. So while stressing, especially at central, it will touch the top of the wall, and while elongation, just it will touch and it will enter the wall also. That is why here load has been given and it is pulled. So same impression, how we can see number 4, practically it is happening. That is why testing is required. Then bond test. Bond test means once it is ground, it should not be slip, or it should not, stamp should not come out. But air limitation is 40. If we cast this beam by 40 D, D means the diameter of sheathing. Here we can see in number 1, cone has been fixed similar to beam, and after inserting the stand, grouting has been done here. Here grouting has been done, and after grouting, we are pulling it with 95% of UTS, and wire should break, but there should not be any slip. And another end, we are using all this equipment to measure whether any slip is there or not. Then test on glue. We have to conduct several. First of all, this spotlight, how after how much time it will set and it will not be workable. Then this compression test. Then for shear, we are having this precast CC block, and glue is applied there, and it make it rectangle. And here load will be there, and after load we have to see this should break, but this glue should not be undisturbed. And these are the parameters: the porthole life, open life, thixotrophy, angle of internal friction. All these parameters is the requirement before going for gluing. Now coming to the execution part, very simple part is eye girder. We will discuss in detail. So first, our activity is methodology approval, shuttering and staging, rebar, DBS, cutting, bending and fixing, anchorages and sheathing profile, concreting, finishing, prestressing, grouting, filling of edges and cold tar epoxy painting, and erection. If case of precast, erection has to be done. These are the requirements. Now, for wherever we are thinking for prestressing, that means measurement accuracy and time is the essence of prestressing. Here measurement, most important is deviation angle, and another is measurement of elongation and slip, and time is when to be locked, and all these three are the issues. Coming to one for deviation angle, this is one photo. Just to see how much accuracy is required. In degree, it has gone up to 3 number, decimal 3, 11.758, not 11.7 or 11. So just to see what is the accuracy requirement here. But in the field, very people are reluctant and not taking care. Just we will see in another slide. We have considered one angle 5.943. How it is achieved? So we have taken in two parts. One part is for fabrication engineers working from contractor, and another part is engineers working as a consultant. So engineers working in the construction firm has to achieve this degree angle, and consultant has to see whether this degree is accurate or not. So we have to have some trigonometrical formula, sin theta equal to p by h. Here p, we have to have this p, and this is 270 I have considered for this required jack, and this is the angle. So sin 5.943 equal to p by 270. So this will 0.103539 equal to p by 270. Therefore, p is equal to this one, 27.955. So if we consider this lower point 150, then this point must be 177.955. Then this degree will be 5.943. Another is, it is fabricated, came at site. Our checking engineer, consultant engineer must check it, but it is not possible to check just by a scale. We have to have one tool, having a square bar tool like this and this. So just to place above the eraser and measure it. Suppose it is 100 and this is 127.955, and we go for this same formula, then theta will be sin inverse this one equal to 5.943. So it is checked. Yes, whatever fabrication has been done, it is correctly. Okay, sir. Vivek, sir.
Yes, sir. You are audible.
Yeah. Okay, thank you. I just received this. This happened at my site, sir. And our engineer, he told, no, sir, I have checked before concreting. After concreting, it has gone. Just to see anyone, is it possible to go like this? Any problem? But he given me so bluff. But luckily, I have seen, no, this angle is not possible. So I put a scale, then I saw, no, it is wrong. Then it was rectified. So now some sequences of activities, whether it is cast in situ or precast, some activities are similar, whether it is eye gutter or box gutter. Like casting bed, it is required for precast. If it is cast in situ, then staging is required. Then bottom shutter we have to fix, and then one side shutter has to be fixed, and cable profile can be marked on shutter itself. Then it will be very easy for profiling. Then reinforcement with lifting hook. If a precast member is there, then lifting hook should not be missed. Then cable profile has to be done, and another side shutter. Side shutter will be placed with an anchor cone, and it should be connected with sheathing also, and positioning of the precast end block. This precast end block I will discuss on another slide how it is important, and any punching, any bursting of anchor can be avoided. Checking of reinforcement and cable profile, fixing of anchor, another side shutter, and checking, concreting, stressing, grouting, filling. These are the common for all. Here photo number 1 is for precast image. It is in casting yard. And number 2, this is cast in situ. And here you can see precast end block has been erected. In number 2, precast end block is erected, and this is cable profile is done. And here one precaution we have to take, just to see photo number 5, how this inverted U bar has been placed here and welded. During concreting, there will be buoyancy because it is hollow and almost weightless in comparison to concrete. So it will go up. So it should be provided, and at the interval of 0.7, as per my experience, 0.7 meter is sufficient. And this number 3, all outer shutter has been placed and concreting was done. This is for box gutter. This is soffit shutter, and this outer shutter, and reinforcement and concreting and stressing. Coming to pre-tension U girder. This construction of U girder has been published in Indian Highway, September 25. This is the detail of U girder. Anyone interested person can see Indian Highway, September 25th. First of all, we have to have bottom shutter and side wave shutter, outer shutter, and then bulkhead. Bulk had been provided in photo number 2. Below the photo number 2 is one close-up photo. Hole is shown in the bulkhead to cross the strand here. Then reinforcement is fabricated at another place, not on this shutter. To just save the time, parallelly it can be done. This is known as jig. For same dimension, we have fabricated for angle section or channel section, and it is casted. This is 30 meter, and 30 meter for lifting of 30 meter is number 4. One lifting truss has been fabricated, and it is lifted, and it is placed here. In number 5, it is placed. After placing, the inner shutter is to be placed. After fixing of the inner shutter, a strand is cut inside, and it is threaded. Before threading, washing is also done to remove the cuttile, and here a removal of slackness is being done with single pull jack. Here, this wall is reaction wall at locking end. All this mono block is there, and this is a jacking end. All 6 jacks are there, and this jack is connected with floating beam. This known as floating beam. And this floating beam is connected with a stand. Once jack pulls this floating beam, this floating beam will pull all the stands simultaneously. So this floating beam should be strong enough, otherwise it can bend. I will show on another how it bend and affect the stretching. Now, for segmental box gutter, all it is same, only it is to be cast in segment, and we have to check the cable profile precisely, because it is cast separately and it is just after touching to each other, their profile should be smooth enough. So casting is almost similar. Then transportation of segments, lifting of segment, dry matching and application of glue, temporary stressing. Then after temporary stressing, threading of ST stands is done. Threading is nothing but insertion of ST stand is technically known as threading here. Then stressing, grouting and filling of races, coal tar epoxy. These are almost common. Here we have to see this segment. This is the profile, and we have to cast in pieces, and after erection and stressing, this cable profile should be as given in the drawing. There should not be any variation. For segmental box gutter, this is the requirement of casting bed. Then this number 2, you can see casting beam is there, bed beam, then bottom shutter and outer bed, and bottom of the deck is there. Here similarly, reinforcement has been fabricated at another place, and with the help of a crane or hydra, it can be shifted here. And after shifting, inner shutter has been fixed. After inner shutter and checking the profile, this bulkhead is fixed. You can see number 3 bulkhead is there. This is shutter having a cable position, and this is shear key. These are the shear keys. Impression will be there. We can see in number 2, this is the shear keys, and after concreting, this collapsible shutter is there, inner shutter, and resting on rail, and it can be taken it out. Once it is cast, it is lifted and stacked in casting yard. It is transported and lifted here. Lifting is in progress, and after lifting, then here dry matching is done. So before lifting, what precaution we have to see? There should not be any irregularity on this surface. Otherwise, there will be chances of leakage from here. Suppose any 2 mm projection is there, then will not touch, and there will be here leakage. So we have to take care. It should be lump free. Any irregularity shall be smoothed before shifting from casting yard. And after erection, temporary stressing has to be done. So a requirement is temporary stressing jack with beam block complete set, McElroy bar for temporary stressing, power pack, glue mixing machine, and hair glove. These are the requirements. And here mixing of glue is being done mechanically, and it is applied. This application should be uniform to 2 to 3 mm only, so that after temporary stressing, it will be squeezed out. This is a temporary system. This is a McElroy bar connecting to here, and here a jack can be seen here, and this is bar connecting to this member, this segment. This is bottom soffit. This is a soffit. Similarly, it is at top also, and it is stressed. It is squeezed out. We can see in number 3 how it is squeezed out. And number 4, this is after erection and pre-stressing. Now coming to stressing, what we are discussing. For stressing, we must have hydraulic multiple jack set. Set means jack, collar plate, and locking plate. Then hydraulic single pull jack, mono jack. Mono jack required for emergency only. Suppose any it is choked or is stuck or broken, then we have to take it out all the stand. So it is required for emergency purpose only. Then power pack, pressure gauge, linear scale, master gauge, wax, petrol, and water. This petrol is required for cleaning purpose, and wax is required to be applied on master gauge. So it should not stuck while in de-stressing. These are the activities. First of all, we have to review the drawings, and whatever elongation has been measured, written, we have to see whether it is correctly written in respect of sleep or not, because sleep is one of the most important and naughty numerical value which affects the stressing system. Then Q we have to test, of course. Then pressure gauge calibration we have to review and verify with traceability. What is traceability? Traceability is documents. That means one pressure gauge is given for calibration. Another pressure gauge is calibrated, whether it is correct or not. That pressure gauge is calibrated in weight system. That should be there. Whether that calibrator has been calibrated or not with weight system. That is known as traceability. Then conversion of force to pressure. Whatever force is given, either it is tonnage or kilonewton. But that force we cannot measure at site directly. We had to equipment to measure the pressure only. So that force has to be converted in pressure. Then calculation for modified gross elongation. Then cutting of a strand, positioning of bearing plate, then working wedge at both ends of the girder, then collar plate and locking plate. This collar plate is responsible to give the place for jack. That jack rests on collar plate. Then locking plate is required to lock working wedge after stressing. Then placement of multiple jacks. Jack we have to place at one end or another end, both end as per design. Then we have to apply wax on master wedge, and power pack has to be connected after fixing and tightening of master wedge, and force has to be applied at the interval of 50 kg per centimeter square, depends upon total required pressure. And elongation we have to measure at every incremental, and then zero correction has to be done after force reading. Zero correction is required because initially there is a slackness. That means after the first pulling of 50 kg, instead of 22 mm, it will be 50 mm or 60 mm so. So that cannot be taken as first reading. So we have to nullify this reading. We cannot take, and we will take the average of another 3, and that is taken as first reading. Then after stressing, we have to lock it with 75% of applied force. Then force has to be released, pressure has to be released. Generally, what people are doing, they are holding the jack at 50 kg and measuring the slip. How it is possible? Once we are holding at 50 kg pressure and we are taking the slip, and what after? After releasing total, then after it will go, and we are very reluctant. We are not taking the measurement after releasing the total force. So, as per my experience, and what I have done is, I am releasing the pressure up to 10 kg, and I have seen at 10 kg pressure, it can hold the jack intact. So, jack will not move. So, 10 kg pressure is sufficient. So, I request all friends to take the reading of slip at 10 kg only. Then you will get altogether 9-10 mm. Then measurement of slip we have to measure and jack to be removed, and we have to calculate the pressure and net elongation in percentage, what are the requirement and what we got. Then preparation of summary sheet for use of dummy cable if required. Then some paperwork we have to do. First of all, we have to convert the force into pressure, then modification of elongation, slip consideration, zero correction, data entry, and calculation of pressure in percentage. And if required, we have to use dummy cable also. Since force is given in metric ton or kilonewton, we have to convert it. So we have taken one force 378.2 metric ton. Now we are going to convert. There is a formula, design force, and since it is metric ton, we have to multiply by 1000 to make it kg. Then ram area in centimeter square. Then jack efficiency we have to consider here. So we got 365 kg per centimeter square pressure is required to achieve 378.2 metric ton. If it is given in kilonewton, then kilonewton it will be 73710 kilonewton. Here kilonewton, we have to go for newton, then we have to convert in kg, to, for which we have to divide it by 9.81. So we will get same thing. Similarly, we have to calculate the modified elongation, because designers are calculating all elongation, everything with a standard area and modulus of elasticity. And it is not possible at site. We have to modify as per actual area and MOE of a stand. So if in the design, net design elongation is 139.1, slip is not added here. It is mentioned their net elongation, design elongation 139. So very nice. With a simple formula, we will see 139.1 multiplied by theoretical E and theoretical area, and this is the actual E and actual area. It comes to 134.36. This is our required, and but during stressing, we are facing slip and elastic shortening of grip length. So we have to add here our this 140 to achieve the 100% elongation. We have to add a 6 mm slip and 4 mm for grip length extension, and 2 mm we have considered if it is one end stressing. So this 2 mm sitting will be there on locking end. That 2 mm is bodily shifting. This is not elongation. This is bodily shifting. Total length is shifted by 2 mm. So in measurement, it will be there, but it is not elongation. That is why we have to deduct it. If it is considering 95% and 105%, these are our limitation. Our means the site people limitation side people have to play between 95 and 105. It is coming beyond this 95 or 105. We have to report immediately to the designer. We cannot put our mind here, or I can assume it may be wrong. Then there will be problem. So we have to report immediately. In some cases, designers are writing including slip. So before calculation, we have to deduct 6 mm. Then same calculation will be there, and then you add it. So, yeah. Then you will get most accurate number for the stressing. So some practical problem what we face is, here we can see number one, this wedge spacing is not equal. Yeah. What will happen once it will go inside? This diameter, outer diameter will get reduced. Then it will touch, and here it will be gap. So then after what will happen? This part will rotate like this. This part will rotate like this. Then there is chances of bite, because this will work as knife. Then it will cut during stressing. If it is there, so with a screwdriver, it should be make it equal before stressing, and after stressing, we can see it is equal. So we have to take care. So these are the components what we discussed. Collar plate. This is collar plate. This jack will rest here only. Then we will place locking plate here. This jack will rest here on this collar plate, and this is locking plate will be used after stressing to lock the working wedge. Another part of jack will push this locking plate. This locking plate will push the wedge, so it will be locked. So after tightening of master wedge, whatever looking wedge is master wedge is being tightened, and stressing is pulling is done. After pulling, we have to measure here. This ram is coming out, and we have to measure whatever ram is there. That means this much strength has elongated, and we have to do one zero correction. Zero correction, I told, because first reading will be more than the requirement. This is 46, and second reading 66. Means 20 mm elongation was there. Here 20, 20, and 21. So average of 3 has been taken here for first one. And after stressing, after pulling all the complete force, we have seen locking end. This was one end stressing. Locking end was marked, and was 100, it 98. That means it was bodily shifted by 2 mm. So actual will be 2 mm less. It is 147, so it will 145 only. Then this 9 mm came as slip. This is the combination of the slip of wedge as well as elastic shortening of grip length. Grip length we have to consider. Generally, it is coming 600 or 650. So it will come in the tune of 4.2 mm or so. So we have considered 4 mm. And after coming, it is coming 136.33 instead of 134.36, 100%. So it came 101%. And pressure is also coming in the same tune, 101%. So this is one example. And after stressing, we have considered 4 cable, and all having 19 stand. And it was stressed. The requirement was 365 kg per centimeter square. But there is a shortfall here. Total shortfall came 20 kg. So for 20 kg, we have to provide a strength. How much? So for one stand can take 19.21. So for 20, it comes to 1.04. So we have to provide one strand for this one. So this is all about stressing. Now one important note, or you can say a suggestion for bridge engineers. What is happening at the last incremental force? Sometimes elongation shoot up. Elongation got out of our limitation. Suppose they are writing step by step, and last requirement is only 2 mm, but our pressure is 25 kg. So while giving 25, instead of 2, it may go 5 mm. So it will jump. So in that case, if it almost reached the elongation, then my advice is to put the scale on ramp and pull the stand. And once 2 mm reached, just stop the pulling and see the what is pressure has gone. Then it will not jump and we will safe position.
Sir, you have 10 minutes more.
Okay, sir. Okay, sir. So
Yeah.
this grouting makes the system. System means concrete and stand, monolithic. So for this grouting, clean and potable water is required. Ice, lime, cement, and mixture. And for equipments, wheel cutter, grout cap, air vent, nipple with locking valve, grout agitator, grout sieve, grout pump, water pump, tube mold, hydrometer, and thermometer. And first of all, we have to see whether any slip is there. If slip is not there, then we have to cut the stand and fix the grout cap. And grout, it is filled with fresh water. See the any leakage. Then cleaning is done with 1% lime water. Grout is mixed and it is filled. Before filling, we have to take a cube also filled. Then duck is filled, and we have to see the grout in and grout out consistency. If it is same, then we have to lock the nipple on another end and open the air valve. And this is the some photograph. It is being cut and grout cap is fixed with nipple. It is being washed. Mixing is done in agitator. In this is the pump and grouting is started. After grouting, we have to remove the set grout cap because she like this. And then recess is filled. Letterbox type shuttering, and after freezing, coal tar epoxy. Now, a remedial measure. What are the problem? Problem is data given in the drawing. So this is regarding sleep only. Sleep is the very critical numerical value, but our designers are taking very lightly. Just to see how they are writing. This is from 3 drawing. They are writing their different language, and no one is writing clearly whether sleep is included or excluded. What poor sight people will do? They will assume anything. If assumption is as same as the designer, then okay. Otherwise, what will happen? 6 mm have a big thing for stressing. If cable profile is not correct, then there is chances of crack like this. So we have to rectify. And if it is not strong, then it will bend like this. In floating beam of U girder, sometimes this reaction wall is tilted. Here you can see first photo, this is at level, and second it has gone up here. Then after the rock anchoring was done here on pile cap. This is the rock anchoring. Sometimes there is a leakage or sheathing is choked. So to avoid this, we have to provide this dummy pipe in single piece. And during concreting, we have to make it movable through and through. And tamping of this shutter will help to avoid any minor honeycomb or air bugs. Sometimes this is reinforcement. Here cable is coming here, this point. So in consultation with the designer, we have shipped this reinforcement like this. We have not done our own. We have consulted the designer and they suggested, then we have done. Sometimes elongation is not similar for both hinges. In that case, what we have to do, if any extra elongation is there that side, that we have to hold, and from a smaller side we have to take first. Suppose 4 mm difference is there, 2 mm we can take first, and then second we have to start. Similarly, by 2-3 steps we can equalize it. By we have seen what was the remedy. Here also you can see how it happened. After stressing, there is a hogging. So this girder rests on this point only after hogging. So there is a crack. To avoid this, we have to make block here only. And this is free. We have make it free. So the load will be here only, not only here. So there will not be any chances of this type of crack. Now major is punching. These are the some example of punching. And punching of anchor cone. Technical paper has been published by JESA in September 2022. And what we discussed earlier, precast end block. This is the precast end block for 50-meter high girder having overall height of 3.8 meter. So it was not possible to cast here in number 4 without any honeycomb. So I suggested the contractor, Techni Bharti was the contractor in Kerala, and he accepted my suggestion, and it was cast like this, and it is erected here. And for box cutter also, we can use like this. Then I am sure there will not be any punching of anchor cone. We will adopt this one. If honeycomb is there, there means problem. This hogging, excessive hogging is there. Girder may bend due to eccentric file. This grout not filled. Problem is this one. This was not at top. This air vent should be here. It is here. That is why it is broken, because the grease was not there. Then if once we apply the grease, there will not be this type of problem. Sometimes during a stressing, we are not using proper side support and it can topple down. This is one of the cantilever beam of metro. It was like this. Then it was clean and studs were used and concreted, finished, and stressing was done. This was 5 cable burst like anything in half an hour. So I suggested to cut this segment, easiest segment, and it was cut with saw cutter, and the saw cutter we have cut S1, 150 mm in S1, where we can see it is taken out. This was the joint, and we have cut 150 mm inside the S1 to weight cast, for weight cast here. And after cutting, it was smooth enough. So we have used shear studs here and hacking, and it was placed, and reinforcement we have placed here, and it was cast. After finishing, you see the metro and metro ring running now. So what type of precautions we have to have? one dummy we have to use. And during concreting, please listen, dear bridge engineer. While concreting of eye girder or box girder near anchor cone, please don't pour the concrete for 1 meter. Pour the concrete 1 meter away from the anchor cone, because in anchor cone area congestion is so critical. Our concrete will not go. Only aggregate will go first. So pour the concrete 1 meter away from the anchor cone, and then after vibration it take it there. So there will not be any chances of honeycomb, or better to have precast block. If any repairing is required, do the repairing before. Don't hide. Don't hide anything. And senior should also do. Their junior people is not hiding and not afraiding anything. All test report should be there. Concrete should be tested before. In case of partial dummy, sometimes dummy cable is there for fully emergency. Sometimes in cable itself, uh, suppose 8 is to be stressed and 4 to be stressed after considering the dummy. So in case, don't place 8 cable. Just wait for final. Then only, and then modification should be done, and consider grip length must be considered. Wedge, all wedge should be equally distant, and a strong ply or wooden barrier should be placed behind jack for safety purposes. We have to check the availability of hydraulic oil also. Sometimes during stressing, what we saw, there is no pressure is coming. What is the problem? There is no sufficient hydraulic jack. So we have to see. So these are the precautions. And by this, I want to say thank you for listening me. Thank you very much, Vivek sir. Hello.
Yes, sir. Yes, sir. Sir, thank you very much. Now you can come, you can shut down the, you can minimize the PPT and come to the webinar, sir.
Okay.
Yeah, you can come to the normal screen.
Okay. Normal screen. Now it is normal screen.
Yes.
Yes, sir.
Yeah, you can even start your camera. There are certain questions which have come.
Okay.
Yeah, first of all, let me thank you for giving a wonderful presentation. And in fact, we were falling slightly short of time because it
Yeah.
should have been another 2 hours session.
Correct,
Right?
correct. So even 2 hours is less
Yeah,
for all
yeah.
activities. Yeah.
For the complete activity, because on the
Yeah,
same topic, when I go to L&T, they give me 1 day to speak on
yeah,
pre-stressing.
correct, correct,
Yeah.
correct, correct.
So, sir, let us start with the questions. There are certain
Yeah.
questions which have come. Yeah, let me start. There is Mr. Swapnil Harekar. He has asked what is zero correction. So I think you have already explained that. Then Mr.
Yeah.
Nihal is from UK. He's asking how the decision made to whether apply pre-stressing or post-tensioning. So he's probably asking pre or post, how to decide that. Hello.
Pre-tensioning and post-tensioning. Yeah.
Yes.
That depends upon quantum of girders to be cast. Because in case of eye girder, if we have to cast, then we can cast 20 meter 5 girders in one series. So cast girder can be cast, 5 girders can be cast simultaneously. So, but for which we need a lot of lands and infrastructure. If quantum is more, suppose 5,000 girder has to be cast, then it is very easy and economical. Otherwise, for 100 girder, it is not economical. So this is the issue.
Yes. Okay. Yeah, there is another question coming up by yeah by Mr. Nihal only. He's asking, is core drilling for compressive strength or petrographic analysis is advisable for pre-stressed concrete? What safety measures need to be undertaken to avoid hitting of tendons? So he wants to take a core, but he is afraid whether it will hit on the strand. So what is your advice, sir?
We have to see whether to take the core. If it is compression zone, then there will not be any problem. If it is tension, since it is weak, concrete is weak in tension, if we will cut it, or a lot of reinforcement may cut. So why it is required to cut the core? If it is stressed means it is already tested. Stressing is itself a test. If it is
Correct,
not a
correct.
stress,
You are very correct,
if it
sir.
is not a stress, then okay, you can take it from anywhere, no issue,
Absolutely,
and you feel it. But if it is a stress,
absolutely.
means it is already tested. Then why it is required?
Agreed, agreed, agreed. Yeah, there is a next question coming up from Nikhil Nishant. He is asking, if the slippage is more than required, then what should be done? For example, if designer has mentioned slip as 6 mm and during stressing 8 to 10 mm has come, what to do? What should we do?
Truly speaking, if you are telling 10 mm slip is there, that means you are honest enough to tell 10 mm. I am telling if it is less than 9 mm, that is not correct, because 6 mm slip has been given assumed by the designer as per system approval. If it is 6 mm, but whatever grip length is almost 600 or 650. So at the rate of 7 mm per meter elongation, 7 6 ja 42, 4.2 mm, we have to add, and this is temporary elongation. It will be released, it will be shortened once pressure is released. So that 4.2 mm plus 6 mm, it is coming 10 mm. That is absolutely correct. So there is no problem. If someone is telling only 6 mm is there, that means no something wrong. They have not considered, but I can consider, not consider, but equipment will consider. They will show the effect. So that 4 mm and 6 mm, it is coming 10 mm. So it is correct. No issue.
Okay, okay. Yeah, then Mr. Sunil Singh has given a compliment, very detailed
Yeah.
site observation and great insight. So that's a compliment to you,
Okay.
sir.
Thank
For
you. Thank you. Thank you to
uh,
Sunil Singh.
yeah, then Mr. Pawan is asking, which is a more effective bonded or unbonded system, and also in terms of monolithic, which has more effectiveness.
Bonded and unbonded means
Yes.
external stressing or internal stressing. Both
Yeah,
are
let us
effective.
assume. Yeah. Yes, sir. Please tell.
So that depends upon design. What
I
is
think
the
IRC
what is the
112, IRC 112 says mandatory grouting is mandatory for internal strands.
yeah, yeah. If it is internal, definitely we have to. Otherwise, it will not be monolithic. We have to have monolithic behavior. So if it is post tension and it is to be placed in duct, it must be. Actually, grouting has a dual properties. One property is it makes the connection with a strand to grout and grout to seeding to concrete. Another is protection. If no grouting, that means rusting will be there in near future. And in Goa, recently has gone, it was due to rusting in strand only because it was not grouted properly. So we cannot think without grout or bonded. Sometimes we have to have unbonded. It is used in the U girder. Suppose in U girder, for 30 meter, maximum is 90. It is not embedded. Some is embedded less than 2.5 meter as per design, because at the end that much stressing is not required, grip is not required. So we are giving the bonding tube as per requirement at the end, 2 meter or 2.5 meter or so. Debonding tube is used, and after concreting, that gap between debonding tube and strength, it is filled with some chemical like a grease modified. So we are pumping inside. So that portion 2.5 meter is debonding, but it is protected.
Okay. Yeah, there are several more questions coming up, but we are falling short of time. So I will take only 2 questions more. So there is one question which I myself have asked.
Then I can reply on WhatsApp.
Yes, sir. So we'll take 2 questions more. One is if a PAC eye girder is bent in plan during application of PAC force, can we rectify that girder or we have to reject it?
That depends on how much bend is there. If bend is 1/250 length, then we have to redesign the diaphragm.
Okay.
1/250. Yeah. As per codal provision. Similarly, hogging is also. Hogging is in the tune of 1 in 300. But geometry we have to redesign once again. I have faced 36 girder was rejected by the consultant. Then contractor approached me what to do. Then I saw only 4 girder qualify for rejection out of 36. But I saw in IRC and BIS, then I saw 32 can be saved. Only highway engineer has to redesign.
Hello,
so
sir.
That depends upon how much bending or hogging is there.
Hello.
Yeah.
Sir, can you just tell me?
There is another question also, which is on the same line for eye girder for 30 meter spans. What is the deflection? So probably you already answered L/250. Yeah, Mr. Please
lateral
proceed.
deflection, sir.
Yes, sir.
Sir, what if it might be lateral deflection, sir? What are the limited for lateral deflection, not vertical?
Yes, sir. Yes, sir.
Sir,
it is L/250.
For lateral also, sir.
Yeah, lateral. Hogging is 300, L/300.
Okay,
But only whether geometric design is permit or not. If it is hogging, there will not be any problem. Even I can say it is more stronger than hogging.
Sir, if 30 meter girder, na, L/250 means 120 mm. Hello?
100 to 120.
Sir, 100 mm is allowable,
yes,
sir?
No issue. No issue. You go through IS code, I have mentioned on slide. If it is hogging, which clause we have to see, and if it is bend, which clause has to be seen. I have mentioned on slide.
Slide? No, sir. Which code, sir? Can you just tell me code number? IRC 112, sir. IRC 112.
No. So 112 is there. Just a minute, please.
Yeah, I think I'll do one thing. I'll share the PPT which is given by sir, a PDF format, and I'll share all the papers which are written by sir in the WhatsApp chat box. now because we are running short of time, and those who are having other questions, because we couldn't take some of the questions, so please drop me those questions in the WhatsApp. So
just sir, I got it. Clause 20.3.1 IS 1343 for excessive hogging,
okay.
and follow clause number 11.4 of IRC 112 2000. Okay.
So I think whoever is asking your name, you didn't tell. I think you got your answer. So probably get connected to sir on WhatsApp, so you can ask your questions. I think all the pending questions which we couldn't take up, sir will reply one by one. And
yeah, you can share my WhatsApp number. You can share my WhatsApp number. I am free to help anyone. Anyone.
Sir is already there in
anyone, anytime. Actually, I am getting energy once any junior fellow is asking some question to me, and I am able to sort out their headache.
Okay, I think that was a wonderful presentation and a lot of practical insights you shared, sir. So, but every good thing has some time limit. So now we have to conclude our session. So I thank on behalf of ISSE, and those who want to ask questions, please feel free through WhatsApp. We can collect those questions by end of the day, and or maybe by tomorrow you can ask. I will share it with sir, and we'll ensure that you get the replies to all your queries. So thank you. I announce a formal closure of the session. Thank you all. Thank you.
How much participant was there? Maximum?
There were on a peak time there were 90 participants were there. Now people are, I think, exiting.
Wow.
Yeah.
Yeah. Oh, 90.
So,
90 is good enough.
Yeah. Thank you. Thank you, everyone. We announce a formal closure. Bye.
Yeah. Thank you. Thank you, sir. Thank you.